Greetings, Professor McKee here with another quick Excel tip your finance professor wishes you knew. In this video, we will learn how to use both the nominal and the effect functions in Excel to convert from one non-annual effective rate to a different non-annual effective rate. This question has multiple steps and uses two Excel functions. I will have some videos which are linked in the description and are in the same playlist as this video, where I go over both functions on less complicated questions, in case you need review on just the mechanics of each function. Now, for any intro finance class, you will be needing to convert between different effective rates, and we professors will both test you directly on this and also create questions where converting to a different effective rate is the first step. So if you want to ace those questions, or at least the first step of those questions, this video is for you. I prepared a question where we are given one non-annual effective rate, the semi-annual effective rate, and we need to convert it to a different effective rate, the quarterly effective rate, because our loan is quarterly compounds, so we need an effective rate that matches our quarterly loan. This is a first step type of question here. Now to start, we're going to put in our initial effective rate, the semi-annual rate, and the number of periods per year. So there is a 2% semi-annual rate here, so 0.02. And the number of periods, this is number of periods per year, and it's semi-annual, so there's going to be 2 periods per year. Now, my equivalent nominal rate is the APR compounded semi-annually, that is equivalent to my 2% effective rate. If you remember, we divide nominal or APR rates by the number of periods to get that effective rate. So if we were to multiply the effective rate by the number of periods, we get to our nominal or APR rate. So if I take B5, our 2%, and multiply it by the number of periods, 4% is my equivalent APR. Now, I need to get the equivalent annual effective rate to this 4% APR. To do that, I would use the effect function. I put in the nominal rate, which I found in B7, and the number of periods this is still a semi-annual APR, so I put in the number of periods over from B6. And 4.04% is my effective annual rate. It's equivalent to the 4% APR and the 2% semi-annual effective rate. But now I'm going to go to a quarterly effective rate. So I put in the number of quarters per year. That's 4. And to find the quarterly, the APR compounded quarterly, I'm going to use the nominal function. So nominal. My effective rate is the annual effective rate, the 4%. And the number of periods per year is the 4 quarters per year. 3.98% is my APR compounded quarterly, and since I need the quarterly effective rate, all you need to do is take the nominal rate and divide by the number of periods, which is E6, and I get 0.995% as my quarterly effective rate. So we've gone through this long process, but we now have our answer. Our interest rate we need to use for our loan is the 0.995%. We've traveled a long way. We went from the semi-annual effective rate to the APR compounded semi-annually, to the annual effective rate, to the APR compounded quarterly, to finally reach our quarterly effective rate. And do note, I'm using cell references throughout this chain of calculations. This allows me to update parameters in case I'm given a new question with different values. So for instance, let's say it's no longer a semi-annual effective rate, perhaps it is a monthly rate. Well, then I can just change the number of periods on my first interest rate from 2 to 12, and everything jumps forward and I get a new quarterly effective rate. This isn't the most quick way to convert between two effective rates. You can always use algebra, and it will take fewer steps. But this will always work, and it does avoid an algebraic solution. I know many students prefer to avoid algebra when doing finance problems. And there is a certain elegance to be able to solve this question within the constraints of these two Excel functions. I will have separate videos where I cover how to handle those individual nominal and effect functions in isolation, not as part of this larger problem. The links to those videos are in the description. They're going to be in the same playlist as this video. So with this procedure, you can now take any question that gives you an effective rate and use it to find a different effective rate if your professor decides to throw one of these questions at you. If you found this video helpful, please comment, like, and/or subscribe so that other students can find this too. Happy studying!